Hi students, so we're going to start by the first chapter, which is complex number. In part 1 we're going to study the rectangular form of the complex number. What is a complex number? A complex number is written of the form z equal a plus bi. What does it mean, a plus bi? I is root minus 1 and a and b belong to the real number. You're going to say this is the first time you can have a square root of negative number. Yes, it's the first time. It's impossible in the real set. It exists in another set which is called imaginary set. We can imagine it. It's called complex set. So the complex set exists only when you have square root minus 1, where z equal a plus bi. Real of z is a, and imaginary of z is the coefficient of I, which is b. So here you can see if b is 0, so z will be a will be real. So that's why the complex the real set is a small set is inside in a bigger set which is complex. Why inside a complex? Because the complex is of the form z equal a plus bi. So if b is 0, we don't have the square root of minus 1. So if the only condition, if b is 0, so this set will be the same as the real set. So that's why the complex set is very huge compared to the real set. So let us take some example. We all know that x squared equal minus 6 is impossible in real, but it exists in another set called complex. So if you want to remove the square, you say plus or minus, as we used to do before, radical, but I have radical minus 6. Because I know I'm working in the complex set, so I can write radical minus 6 as radical minus 1 times radical 6, and radical minus 1, to say it's a complex, so I write it as I. So it will be plus or minus I radical 6. Always I is called imaginary. Imaginary means complex. If x squared equal minus 16, it's impossible in R, but it exists in complex set. So if you remove the square, same story, plus or minus radical minus 16. So radical minus 1 that you have here is I. You can see it. And radical 16 is 4, so it's plus or minus 4. Radical minus 3, we can, if we're working here, suppose we're going to say, suppose we're working in the complex set. So x equal radical minus 3, directly it's I radical 3. In these cases, in these examples here, this the complex number here, I don't have a, that I have it alone. So here a is 0 and b is a plus or minus radical 6. Here a is 0 and b is a plus or minus 4. Here the same story, radical minus 3 is radical minus 1 times radical 3, so it's I radical 3. Radical minus 8, it's I radical 8 because I have radical minus. So, and radical 8 is 2 radical 2 with I. When you have a is 0 and you have only I, this is called a complex, it's called pure imaginary. What does it mean, pure imaginary, when a is 0? So if a is 0, you have only of the form bi, so it means that we have a pure imaginary number. However, here you have z minus radical minus 6, so it's radical minus 6 is I radical 6, so you have 7 minus I radical 6. This is not pure imaginary because I have the 7. So the real of this complex number here is 7, and the imaginary is minus radical 6. And here the same example, radical minus 25, this is radical minus 1 is I, and radical 25 is 5. So this is the real part and this is the imaginary part. So a complex number is a complex of the form a plus bi. For example, if you have 2 plus 3i, it means I have 2 plus radical minus 9. But I don't write it as radical minus 9. To say I'm working in complex, I introduce instead of radical minus 1 as I, to say I'm working in the complex. So properties, we said that I is radical minus 1. If you square it, you remove I square, you remove the square roots. So if you remove the square root here, as you can see, it will be minus 1. So in that case, I square is minus 1. We know that I square a number to be minus 1 is impossible, so it exists only in complex. If you want to find I cube is I squared times I. Since I squared is minus 1 times I, so this is minus 1 and times I, it will be minus I. I4, it's I square and you square it. I square is minus 1. If you square it, it's 1. What do you realize? We realize that if the power is odd, we have a pure complex, I and minus I. If the power is even, we have an ordinary real number. But all of these are complex, by the way, because all the real number is inside the complex. If you continue here, after I4, you have I5. I5 is I4 plus 1. So if you split it I4 times I1, we know that I4 is 1, so it's I. If you do I6, I4 plus 2, I4 as we said here is 1. So it's I square minus 1. I7, it's I3. I8, it's 1. I4 and I4, 1. If you continue, I power 9 is I8 times I, but I8 is 1, so 1. I10 minus 1, same story. I11 minus I12 is I. So 1. What do we realize? We realize that we have 4 parts. If it's a multiple of 4, like here, I power multiple of 4, the answer of I power multiple of 4 is always 1, like this one. If it's a multiple of 4 plus 1, like I1, I5, I9, so it is I. If it's a multiple of 4 plus 2, as you can see here, I6, I10, so it's I square, which is minus 1. And if it's a multiple of 4 plus 3, like this one, 4 plus 3, 8 plus 3, the answer is always minus 1. So what do we need to know? We need to know the following. If it's I power multiple of 4 is 1, I multiple of 4 plus 1 is 1, is I multiple of 4 plus 2 is minus 1, I multiple of 4 plus 3 is minus I. So let us take example, I power 29. 28 is a multiple of 4, right? So 4 times 7, you know it's 28, so remains 1, so it's I power 1. 18, it's a multiple of 4 plus 2, so remains I square if we do the division. I square is minus 1. I43, it's a multiple of 4 plus 3, so I3 is minus I. I20 is a multiple of 4, so the answer is 1. So let me correct it here. So here the answer is 1. So it's plus, sorry, here, plus 1. Okay. So okay, so let me correct it again. So I20 is 1 because it's a multiple of 4. If you want to simplify here, I11, we all know if you divide by 4, the remainder is a 3, so 2I cube. I16 remainder is 0. 42 remainder is 2. 83 remainder is a 3 again. I square is I square, I is I, and 22 remainder is 2. So 2I3 is minus 1, so it's minus 2I. I0 is 1 because no remainder, so it's like this one, 1. So minus 7. I square is minus 1, so times 2 is minus 2, you can see it here. I cube is minus I times minus 3 is 3I. I square is minus 2, minus 1 times minus 2 is plus 2. And here you have minus 3I, and I square is minus 1, so minus 2. So now we can add the real together and the imaginary. Real is minus 7 minus 2 minus 9 plus 2. Here we have, so you have plus 2 and minus 2 cancel out, so here we have minus 7. And if you want to add the I, you have minus 2I, 3I minus 3I cancel out, I'm left with minus 2I. Okay, here minus 2 and minus 2 cancel out, we have minus 7 minus 2 is minus 9, so it was correct. I didn't see the second one. So minus 9 minus 2I. Now if you want to do square here, we know that I square is minus 1, you have a 3. I11, if you divide it by 3, by 4, remainder is 3. And I cube is, as you can see here, it's minus I times minus 2, it's 2I. I have a plus b square, you all know it's a square, plus 2ab, don't forget the 2ab, plus b square. If you square the first, it will be 9. 2ab, if you multiply here, 6i times 2 is 12i. And if you square 2i, it will be 2i squared. But 2i squared is minus 4. 9 minus 4 is 5 plus 12i. Simplify and write in complex form. Okay. So 2 minus radical minus 5, as I said, because I want to write in complex form, I cannot leave it as radical minus 5. So I introduce the I. Radical minus 2 times radical minus 3. Radical minus 2 is I radical 2. Radical minus 3 is I radical 3. So it will be I square radical 6. But I square is minus 1, so minus radical 6. Here you cannot start multiplying unless introducing I. 2I radical 5. Into I radical 3 plus radical 5. So radical 5 times radical 3, radical 15. And you have here 2i squared. Radical 5 times radical 5 is 5 times 2i is 10i. Now we know that I squared is minus 1. So it will be minus 2 radical 15 plus 10i. Here you expand. So 2 times we must put here radical 5i and here radical 3i. So 2 times 2i radical 3 is 4i radical 3. 2 times 2 here is 4. Here radical 15 and you have minus 2i squared, radical 15. And the last one, you have minus 2i radical 5. Now, this is 4i radical 3 plus 4. You have I squared, it will be minus 1. And you have the minus, it will be plus 2i radical 15 here instead of 10. And you have the minus 2i radical 5. You can put this is the imaginary and this is the imaginary together. You can put I in factor. You have 4 radical 3 minus 2 radical minus 2 radical 5. And for the real part, you have the 4 and you have the 2 radical 15. So you can write it alone. This is the real part. This is A. And this is the imaginary part, which is B. It's always of the form, as we said, A plus IB. Here you have you have a square, but before radical minus 5 is I radical 5 square. So you square the first one is 4. 2ab, it will be minus 4i radical 5. And b square, if you square here, you're going to get 5i square. 5i square is minus 5 here. Minus 5, 4 minus 5 is minus 1, minus 4i radical 5. This is a complex number where the real part is minus 1 and the imaginary part is minus 4 radical 5. Now we're going to start by the conjugate of a complex number. If z equal a plus ib, then the conjugate denoted by z bar. This is the notion of the conjugate. So it is a minus ib. So I keep a as it is, but I change the imaginary. We know from before that a minus b into a plus b is a square minus b square. So before, let me tell you. So what is the conjugate of 4 plus 3i? The conjugate will be 4 minus 3i. What is the conjugate of 7? Because I don't have, it is 7. I don't change the real part. What the conjugate of 2i is minus 2i. Only you change the I. If you have 3 minus 5i, the conjugate will be 3 plus 5i. Why the importance of a conjugate? The importance of the conjugate, if you multiply a plus ib into a minus ib, so it's of the form x plus y into x minus y, it's a square minus b square. So it will be a square minus I square b square. But I square is minus 1. Because I square is minus 1, so minus times minus, it will be plus. So please, from now and on, a plus ib into a minus ib is a square plus b square. But a minus b into a plus b ordinary one is a square minus b square. This is in the real, and this is where in the complex, because I have I. So here, if you have 2 minus x times 2 plus x, here you don't have I. It's 4 minus x squared. But because I have the I, you can say that directly. You can say this is 4 minus 9i square. You can say this is 4 minus 9i square. But I square is minus 1. You can say it's directly 4 plus 9. So always a minus ib a minus ib into a plus ib, it's a square plus b square. So here I can say directly it's x squared plus 49. So if you want to factorize x squared minus 100, this is in real, I don't have I. So it's x minus 10 into x plus 10. 9 minus 7y squared, it's 3 minus root 7y into 3 plus y root 7. X squared plus 25, if you want to factorize, and you can factorize in complex, so you say this, because I have a plus, it's a squared plus b squared, so it's a plus ib into a minus ib. So you write x plus 5i into x minus 5i. So you introduce I. If you have 100 plus x plus 2 squared and you want to factorize in complex, you say it's 10 plus I into x plus 2 into 10 minus x plus 2i. Okay? Now we're going to start by dividing by a complex number. So always when you want to divide by a complex number, you need to use the conjugate. And always the divisor must be of the form of a plus bi, where a is positive. Let us start by the example. Suppose you want to divide 2 over 2 minus 3i. I want to find the answer. I have a number over a complex. So what do? You have down 2 minus 3i. So you multiply by the conjugate. Conjugate of 2 minus 3i into 2 plus 3i, up and down. Why I multiply by the conjugate? Because a minus ib into a plus ib is a square plus b square, so the answer will be 4 plus 9, so I don't have any more complex down. So I can say here it's 4 plus 6i. So if you split, it will be 4 over 13. This is the real part, and this is the imaginary part. So here you had a number over a complex. The answer is a complex where the real part is 4 over 13 and the imaginary 6 over 13. If you have this one, complex over complex, I need to find the answer. So I multiply the conjugate by 3 plus I, 3 minus I. So the answer will be 6I minus 2I squared. But minus 2I squared, directly you can write it as 2. A plus ib into a minus ib, it's a 2 plus b2, so it's 9 plus 1, which is 10. So you can split, so 2 over 10 and 6 over 10. So this is the real part, which is 1 over 5, and the imaginary part 3 over 5. Now I told you always write it a plus bi, where a is positive. Here you can see that a is negative. So multiply all by minus 1 up and all by minus 1 down, not to change anything. So you're going to get minus 2i plus 1 and d down 3 minus I. Now you multiply by the conjugate of 3 minus I, which is 3 plus I. You expand. Minus 6i minus 2i squared directly plus 2 plus 3 plus I over 9 plus 1. So the answer will be 5 over 10 minus 5i over 10. So the real part is half and the imaginary part is minus half. Here you have minus I minus 2. Always start by the real one. Minus 2 plus I, because it's negative, multiply up by minus 1, down by minus 1. So it will be minus 2 over 2 minus I. Multiply by the conjugate 2 plus I and 2 plus I. What do we get? Minus 4 minus 2I over 4 plus 1, a2 plus b2. So it will be minus 4 over 5 and minus 2 over 5. This is the real part and this is the imaginary part. Here you have radical minus 3. Before you start, you must write it as I radical 3. The real part, and you have, we don't have a real part, you have only I. You can put I in factor and multiply by the conjugate, which is minus I. So you're going to get here minus I radical 2 over here minus I square. Here you have minus I square, it's 1 radical 3 minus 2. Here a is 0 because I don't have real. So this is the real part is 0 and the imaginary part is minus radical 2 over radical 3 minus 2. So as you can see, dividing a complex number by a complex number is something very simple. Now factorize. So x squared minus 9, you all know it's in the real. Factorize, I'm going to add in C in the complex. So here you can say x minus 3, x plus 3. So it's equal to 0. Either this one is 0 or this one is 0. So you have to answer x equal to 3 or x equal minus 3. This is in real part. Here I have the plus, but I can factorize in complex. So it will be x minus 3i into x plus 3i. So two product equal to 0. either x minus 3i is 0 or x plus 3i is 0, you're going to get x equal 3i or x equal minus 3i. You can say, for example, x squared plus 9 is 0, so x squared equal minus 9. So x equal, because it's in complex, plus or minus radical minus 9. And radical minus 9 is plus or minus radical 9 is a 3, and the radical minus 1 is the I. Here also the same story is of the form a square plus b square. So it's a minus ib into a, sorry, here you must have a plus, one of them is a plus. So the answer here will be x, it's equal to 0, either x plus 1 minus 5i is 0 or x plus 1 plus 5i is 0. So x will be minus 1 plus 5i or x equal minus 1 minus 5i. So all are the same. Problems. Given a complex number in C, find Z so that you have this product. So what do we do first? We put Z on one side. So we take this one to that side and the number to the other side. Everything without Z to the other side. So Z into 2 minus 3i minus 7Z equal 2 minus 2i minus 5. So you can put Z in factor. You have 2 minus 3i and minus 7 equal 2 minus 5 is minus 3 minus 2i. So directly Z will be minus 3 minus 2i over minus 5 minus 3i. So since the real part here is negative minus 5, so multiply all by minus 1 up and down, and then multiply by the conjugate, as we did before. So here you're going to get 25 plus 9, which is 34, and if you expand here, you're going to get this up. You can check it by yourself. Solve for x and y. Here they didn't say that x and y are complex. Here they said z is a complex. So what do? We expand, as you can see, 6ix minus 10i minus 2yi plus x equal y minus ixi plus 2. Two equality are equal since we have complex. When real, this is a complex number and this is a complex number. Two complex numbers are equal when real equal real and imaginary equal imaginary. So the real part here is 6x, the things with the I, minus 10 minus 2y, and the real here is only minus x. The things without I, the real part is x, and the real part here is y plus 2. So here I have two equations, two unknown. So 7x minus 2y equal to 10, and x minus y equal to 2. So if you solve it, you're going to get, using a calculator, that x is 6 over 5 and y equal minus 4 over 5. Okay, till now. Equation of second degree. So we know that from before, solve f of x equal to 0, we do delta. We know if delta was positive, we have two roots. We know that the two roots are minus b plus radical delta over 2a. It can be 1 times is plus and 1 time is minus, plus or minus. And if it's delta equal to 0, you have x prime equal x double prime, which is minus b over 2. You took this in grade 10 last year, minus b. What about if delta negative and we're solving in second degree? You're going to have here a negative value. So to be positive, what do you write before I? And you put absolute value inside. So that's what I meant here. So let us take an example. Suppose you want to solve this one. Delta is b squared minus 4ac. We're solving in C. B squared is 16, minus 4 times 5 is minus 20, so negative. So two complex root. If I don't mention that we're solving in complex, you say impossible. But if I mention solve in C, so you need to continue. So x equal minus b, which is 4, plus or minus radical minus 4 over 2a, which is 2. Since I have radical minus 4, so I introduce this I, and radical 4 is 2. So I have two complex root, 2 minus I or 2 plus I. So if you want to factorize it as we did in grade 10, so f of x equal to a, here a is 1. You bring everything to that side here and here, you're going to get x minus 2 plus I into x minus 2 minus I. For the second one here, if you want to solve, you do delta b squared minus 4ac, so 4 minus 40 minus 36. So two complex roots, so minus b plus or minus radical delta over 2a, radical minus 36 is 6i. You have these two roots and you can factorize it the same. Let us take some examples now concerning the complex root. So as we said before, two complex numbers are equal if real equal real and imaginary equal imaginary. We did a problem similar up. Find a and b given. So here the real is 2a without I, 7. Here it's 2. So 2a plus 7 is 2. The imaginary minus 3 minus 3b without the I equal minus 3. So b is 0 and a minus 2.5. Here the same thing. When we say 0, it means 0 plus 0 I. So the real part here is if you expand 2a minus 4i minus 21ib minus 14 minus 4 plus 2i equals 0 plus 0 is 0i. So the real part here 2a minus 14 minus 4 minus 18 equal to 0, and the imaginary minus 4 minus 21b without the I minus 4 minus 21b plus 2 equal to 0. So you have this. Okay, here you have minus 4i and here you have plus 2, so this will be minus 2. So the answer will be minus 2 over 21. Okay, find complex number given. Find complex number z. So we did a problem similar. So here we expand 2z minus 6iz plus 12i square equal this one. Here you have 12i square. It will be minus 12. We put z on one side as we did here. Everything to the other side. So then you put z in factor. So complex over complex, because this is negative, you multiply all by minus and you multiply by the conjugate. Find x and y so that you have this one. You know that a plus b squared x squared plus 2ixy minus I squared equal 2 minus 4i. The real part is x squared minus y squared, and the imaginary 2xy equal minus 4. So here y equal minus 2 over x. You replace it here. So here you have same denominator, which is x squared on both sides. So x4 minus 4 equal to x squared. So we have an equation of second degree where the power is 4. So don't do it. So let us skip it. Okay. So property, if f of x is a polynomial whose coefficients are real, then if a plus root b is a root b, when we took the delta, we have b squared minus 4ac and x prime equal minus b plus radical delta over 2a you have, and one is a plus, one is minus. So always if a plus root b is a root, a minus root b is a root, and if a plus ib is a root in complex, a minus ib I root b is also a root. Now write a polynomial whose roots are 2 minus radical 3, 2 minus I. X equal minus 3. So because x equal minus radical 3 is a root, so its conjugate x equal radical 3 is a root. If you have x equal 2 minus I is a root, it's also the conjugate 2 plus I is a root. Concerning the x equal to 2, it's a real number, ordinary number, integer. So you keep it as it is. You have a into x minus 2. Because x equal to 2, you take it to the other side, minus 2. And you have x plus radical 3 into x minus radical 3, as you can see, x minus 2 plus I and x minus 2 minus. Same here, if you have x is 0, so x minus 0 is a root, as you can see. If you have 2 minus radical 3, you have the conjugate also 2 plus radical 3. So if bring it to that side, it will be x minus 2 plus radical 3 and x minus 2 minus radical 3. If you have 3i, the conjugate is minus 3i. You're going to get x minus 3i into x plus 3i. So here we are writing a polynomial whose roots are these. Okay, so this is for the first video. It's enough till now. In the second video, I'm going to talk about dividing polynomial by a polynomial as a recall, and how to factorize an equation, a polynomial, and to find its root if it's complex or not.